Okay, this is question 6 of the WJEC Additional Maths paper 2015. Okay, this is solving a pair of simultaneous equations where one equation is a quadratic, which gives us a curve on the graph, and the other equation is linear, which gives us a straight line on the graph. And the points of intersection are obviously where the straight line crosses the curve. And those 2 points, both of them will have an x coordinate and both of them will have a y coordinate. So we've got to find 2 x values and 2 y values to answer this question. Okay, there's a clue in the second part of the question saying use an algebraic method. That's okay, obviously I was going to use that because there's no graph paper or anything to draw the graphs. And give your answers correct to 2 decimal places. And that tells me when I've started my method, I won't be able to factorise and find my 2x values or 2y values. This is telling me that the numbers are not factorisable, so not nice whole numbers. We're going to get some awkward x coordinates and y coordinates where the straight line and curve intersect. So I'm going to have to use completing the square, or at normal GCSE you would use the quadratic formula. Okay, the method we're going to use is substitution. We're going to substitute the linear equation into the quadratic. So basically y equals 2x plus 1. Instead of y, I'm going to write 2x plus 1. So I'm just going to write that straight away on the first line. So 2x plus 1 equals x squared plus 6x minus 5. Okay, so all I've done, instead of y in my equation of the curve, I've replaced it with 2x plus 1 from my linear. Now I'm going to rearrange this until I have a quadratic equals 0, because we always make them equal to 0 so that we can then solve them. What I need to do is to get rid of this 2x plus 1 to leave behind 0. So what I'm going to have to do both sides is subtract 2x plus 1. So if I subtract 2x plus 1 from this side, I get 0. If I subtract 2x plus 1 from this side, well, x squared stays x squared. If I take 2x away from 6x, I get 4x. If I take away 1, take away plus 1 from minus 5, I get minus 6. Now, as a quick glance, we can see this can't be factorised because it's just an x squared quadratic equation. The 2 numbers that would appear in the brackets, if I could factorise, the product would have to be minus 6 and the sum would have to be 4. Well, looking at the factors of 6, 1, 6, 2 and 3, none of those pairs can be used to make 4. So it can't be factorised, which is what I already thought that because of the 2 decimal places in the question. Okay, so I'm going to use completing the square because this is additional maths, not normal GCSE. So what we're going to do is you have to put a pair of brackets, x inside the bracket and squared outside. When you expand this, that x squared gives you your x squared in your quadratic. Now the number that goes with x is always half the coefficient of x. The coefficient of x is plus 4, half of plus 4 is plus 2. Now when we expand this bracket, we always end up with an extra of this number squared. So I have to take away this number, 2 squared, to cancel it out. And then the constant term in our quadratic equation above goes on the end. So this minus 2x squared, this minus 2 squared cancels out the 2 squared that I would get extra when I expand that bracket. Because all of this must equal x squared plus 4x minus 6. Okay, so the first thing to do is combine minus 2 squared and minus 6. Minus 2 squared is minus 4. Minus 6 gives me minus 10. Remember, you're only squaring the 2 here, you're not squaring the negative sign. If you were squaring the negative sign, the minus 2 would be inside brackets, and we'd say minus 2 all squared. But this is just minus 2 squared, which is minus 4. Okay, now to solve this equation, after we've completed the square, which we have now done, you simply eliminate everything on this side until you're left with x. So I'll get rid of the minus 10 first by adding 10 to both sides. So then I have 10 equals x plus 2 all squared. I then need to get rid of the the squared. And to do that, I'm going to square root both sides. I'll just write that here, reference. So the square root of 10 And the square root of all of this leaves me behind with x plus 2. It cancels out the squared. Now, before I subtract 2 from both sides, I must point out when you square root a number, any number, it has a positive and a negative solution. So we need to write plus and minus in front of there. When you find the square root of a number with Pythagoras Theorem, when you're working at length in a triangle, the answer is always positive because it's a length in a triangle and you can't have a negative length. But if you think about it, if you just square root a number, for example 25, then that could be plus 5, because plus 5 times plus 5 is 25, but it could also be minus 5, because minus 5 times minus 5 is also plus 25, because the minus times minus is a plus. So we have to write a positive and a negative symbol in front of our root, showing that there's 2 answers to the square root of 10. Right, now we take away 2 from both sides, and we have plus or minus square root of 10 minus 2 equals x. So our two solutions are plus the square root of 10 minus 2 or minus the square root of 10 minus 2. Now we need to do this on a calculator. So I'm going to get my calculator. I'm going to do square root of 10 first, minus 2, and I get 1.16227766. And we've got to go around to this corrected 2 decimal places, so that is 1.16 to 2 dp, or x equals, so now I'm going to do minus root 10 minus 2. So minus root 10 minus 2, and this time I get minus 5.16227766, which is minus 5.16 to 2 dp. Okay, I found my two x coordinates of the point of intersection. Now I need to find my y coordinates. Well, what I'm going to use is the linear equation here. Y equals 2x plus 1. So all I have to do now is substitute my first x value in and get the corresponding y value. And I substitute my second x value and get the corresponding y value to go with that. And then we're done. Okay, so let's do it. So y equals, I'm going to write the equation first, 2x plus 1. Now, just to be as accurate as possible, I'm going to substitute in the unrounded answer first. Okay, so y equals 2 bracket 1.16227766 plus 1. So y equals, now I'm just going to type that into the calculator, 2 bracket 1.16227766 close brackets plus 1 equals 3.3245532, which is 3.32 to 2 decimal places. So when x was 1.16, y was 3.32. The other one then, I'm going to substitute the other one in by here. So y equals 2 bracket minus 5.16227766 plus 1. So I just go into my calculator. All I need to change is the 1 point into minus 5 point. Press equals. I get minus 9.3245532, or minus 9.32 to 2 decimal places. Now, because they want the coordinates of intersection, just double check. 5 find the coordinates of the points of intersection. I'm going to write them as coordinates. So the points of intersection are, well, the first one we got 1.16 and 3.32, because when I used 1.16, 227766, I came up with 3.32. So that rounds to 1.16, that rounds to 3.32. And the other one, when I used minus 5.16, which it was to 2 decimal places, it came up with a y of minus 9.32. And there we have our 2 points of intersection of the straight line and the quadratic curve. Okay, thank you very much.